Hello, everybody. Today we're going to be going over free fall problems in physics, usually covered in Unit 1 of AP Physics C. So let's get started. Here are some essential formulas to know. So here we have the displacement, otherwise known, you can also say the distance, is equal to the initial velocity times time plus 1/2 the acceleration times the time squared. The final velocity is equal to the initial velocity plus the acceleration times time. So those are the two essential equations you're going to need to know to answer these questions about this free fall problem. So let's say we're rolling a rock from rest state off of a cliff into the water. Let's say that we're going to say that its initial velocity is 0. So how we tackle problems like this is we just write down all the information we know. So the initial velocity is equal to 0 because we're dropping it from a rest state. We're essentially just dropping it straight down. Okay. And our first question, what is the speed of the rock after 5 seconds? So we want to ideally find the velocity of the rock. And we don't know that yet. So we're just going to put a question mark. So, and part A says, what is the speed of rock after 3 seconds? So we're going to have to use t equals 3 here in terms of our units. And then our acceleration we know is equal to negative 9.8 meters per second squared. And how do we know this? Well, in free fall problems, objects are acting at the force of gravity. And in this case, the reason why that's negative is because we're moving in the negative y direction. Okay. So the speed of the rock after 3 seconds, we want to know v sub f, otherwise known as our final velocity. So let's use all of our information and find the final velocity. So if we just go over here, okay. So let's go down. Okay. So the final velocity is equal to our initial velocity, which we referenced up there was 0, plus the acceleration, which is negative 9.8, times the time, which is 3 seconds. So in total, this 0 does not matter. We don't need to worry about that. And then we can just say that our final velocity is equal to negative 9.8 times 3, which is equal to negative 29.4 meters per second. This is the velocity. However, we want the speed. The speed is just equal to the absolute value of the velocity. So we're just going to say that the speed is 29.4 meters per second. Because remember, speed is a scalar quantity and velocity is a vector quantity. Let's go over to the next part. What is the velocity of the rock after 3 seconds? So as we said here, our velocity is negative 29.4 meters per second because we're essentially moving in the negative y direction, and that's how fast the rock is moving in that direction. So remember, velocity, that is a vector function. It takes into account the direction of the movement. Okay, and how far did the rock travel during this time? So if we go over here, one of the most essential equations in physics is this equation. D equals the initial velocity times time plus 1/2 acceleration times time squared. The time squared is for the fact that acceleration is measured in time squared, like meters per second squared, and for velocity it's just time because we measure in meters per second. So that's a good way to think about it. So if we use our formula here, d equals v naught t plus 1/2 at squared. Well, we know all this information, so what we're going to do is we're just going to say our displacement or distance, either one, is going to equal the initial velocity, which we know is 0, times our time, which is 3 seconds, plus 1/2 times 9.8, negative 9.8, times 3 squared. Okay, so our 0 times 3 is going to cancel. We're not going to have that. And then we're going to have 9.8 divided by 2, or times 1/2. And this is negative 4.9 times 9 is going to equal our displacement. So when we multiply these numbers out, we get 44.1, or negative 44.1. Let's keep consistent with the colors. Negative 44.1 meters. Now, how far did the rock travel? Well, the rock actually traveled 44. So the distance, this is going to be 44.1 meters. Okay, and the reason that is because, remember, distance is a scalar quantity and displacement is a vector quantity. So when we have the displacement, this is going to be negative 44.1 because we need to specify a direction. In this case, we're moving in the negative direction, the negative y direction. Hope everybody liked this short, quick tutorial on free fall physics. Press like for more physics videos, and goodbye.